Hey everyone, welcome back. In this video, we will see the third component of our project, which is data preprocessing. Now, let's start coding from config entity, configuration, and our component. Let's go into the code. As I said, just start with config entity. Here, we just create the configuration which is required for data processing component. So let me write it as data pre-processing config is equal to name tuple. Here we need some informations. So those information you can just see it over here. They are model name, which you can see here XLM Roberta, and the class, number of epochs. All this information should be given inside this name tuple. So let me write it. So we need model name, tags, index to tag, tag to index, and the tokenizer. Now the next step is we have to go inside configuration where we connect this YAML file to this name tuple. So let's go into configuration. Here you can just start writing the third configuration, which will be get data preprocessing config. All you have to do is just make use of this variable, which is config, which will be a dictionary. We will just take the information and then connect it to name tuple. So let me start by creating the try block, and then model name is equal to self.config. Here we just give the base model config, and inside which we will give base model name. The next step, we have to take in the tags. So I will just put it over here so that it is easy to follow. So for tags, we have to go inside key, and then we have to make use of this NER tag key. So let me write config, and inside config I can just give data preprocessing key. All these variables will be assigned already in constant. So let me show it here also. So every keys which are present here will be taken as an variable here, so that all these constants can be used. So let me write data preprocessing key and the NER tags. So for that we have named NER tag key. The next step is we have to take index to tag. If you remember, we have done this in our Jupyter notebook. So let me write it as IDX. Let me show you the code here. So we will be using this code only. And in the next step, we have to take in the tokenizer, which is used for data preprocessing. So for that, let me load auto tokenizer, which we have imported, and then call from pre-trained. And here you just call self.config, and here we just call it as base model config and the base model name. So what we are doing is we are just taking XLM Roberta tokenizer. And next, let me write data preprocessing config. This will be a variable name. Now let me call the configuration which we have created in the config entity. So this will be called inside configuration. Let's import that and then call it here. Now once you call it, just call the model name, which will be XLM Roberta. You just give the model name here, and tags will be tags. This is also taken from our YAML file, and the next will be index to tags and tag to index, and next is tokenizer. Let's give the tokenizer inside. Now let us return this configuration here. Return data preprocessing config, and let's close the try block with except block exception as E and raise custom exception. And that's it, guys. This is the configuration which will connect our YAML file to the given name tuple. Now let's import this and make use of this in our third component. Let's go inside component and then create a new file called as data preparation.py. Let's import all the required libraries. I will import exception first. Exception, import custom exception. This should be from import custom exception, and then from ner.entity.config entity import data preprocessing config, and let's import logger from ner.logger import logger, and let's import sys, and from typing import any and dict. I think this is enough for now. Let's start writing our class, which will be data pre-processing, and let's create our constructor, which is init, and then data pre-processing config. This will take in the data pre-processing config, which is nothing but our name tuple, and data will be any, and let's call this config here and call the data again. Now all you have to do is create the tag name which we have created inside configuration itself. Let's call it tag name, and the batch, you can straight away return it as NER tags str. Okay, this should be string, and this can be a list which contains our index to tags. So I'll just call this dot index to tag, and this will be index for idx in batch of NER tags. So if you give the batch, and that in that batch it will convert index to tags. So this will give the exact tag name based on the index number. Let's write this tokenize and align labels which we have created inside Jupyter Notebook itself, and align labels. I think we can just go there and check. Oh, so this is what we are going to write over there. So if you remember, this is basically used to align each and every subwords. So it also ignores the subwords by assigning -100 to those indexes. So let me write it as. So what I have written here is, we just call the logger.info tokenize and align labels. We are just logging the information, and then we take the tokenizer by data preprocessing config.tokenizer, which we have created here. This tokenizer is loaded, and then we tokenize the inputs which is given, and then we create an empty list. Inside list we just iterate through each and every data, and then we tokenize the word IDs. So if you remember, if we tokenize the word IDs, it will be created as words into multiple subwords. So those subwords doesn't have any meaning towards the word. So what we do, we assign -100 for the label IDs so that it will be ignored while training. So I have explained this very clearly in Jupyter Notebook section, and I also given the example over here. So if the word ID is for the first time, we assign the word label ID. If it is repeated again, we assign -100. So that's it. We just assign -100 to the subwords and then get the tokenized inputs. Now let's close the try block as exception and then raise the custom exception. This will be E and sys. And the next function will be encode en dataset. This will take in the corpus. If you see here, this is the function which we are writing here. It will take in the corpus and it will map the function, this function, and then we are setting batch as true. So it, for each and every batch it will map it, and then we remove the columns and make it as indexes. So all this tokenization method will be applied to each and every points of dataset. Try. We just return corpus dot map, and we just call self dot tokenize and align labels. We just call that function, and then batch is equal to true. Next we just remove the columns. Remove is equal to lengths, NER tags and tokens. So we are just mapping the corpus. Next we just close this and raise the custom exception. I think this will be very clear. If you are given a corpus, it will iterate through each and every data point and then it will tokenize it. Next, let me create the final function. So this is a function which calls all these three methods inside. Let's call it as prepare data for fine tuning, and this will be returning a dictionary. Let me write try block here. Here we just call self dot data is equal to self dot data, which is here. This we call this data inside, and then we map it with self dot create tag names. So we are just creating the tag name for each and every data points. Next we just call panx en encoded is equal to self dot encode en dataset. We just call this en dataset, and then we pass the data inside. First step, we have created the tag name based on the index, and then if you remember, our data set will have only index, it won't have the exact tag names. So we are just creating a tag name here, and then we are encoding it in the next step. Once it is encoded, we can just return panx encoded. Let's close it as now it is done. And that's it, guys. This is the data preparation component. In this component, we just take the data which is already validated by data validation component, and then we take it and we load it inside. Once we load it, we just create tag names. Basically, if you see the original data, it will contain only index number instead of the tag name itself. So we just create the tag name first, and then we put it to tokenizer, and then we get the tokenized output. Once it is tokenized, we have multiple subwords and words. So all these subwords are mentioned as -100, and the original words will be having the label IDs, and that label IDs will be passed for training. So here we just prepare the data, and once the data is prepared, we just put it for training. So in the next video, we will just create the model architecture which we have created over here. Let me show it here. We create this model architecture, and then we call this model for training, and let's create both of these components. Hey everyone, welcome back. In this video, we will be seeing the component model trainer. Before that, we will be creating model architecture which will be passed to this model trainer component. Now let's start coding. As usual, to start a component, we have to start with config entity. So let's create our config entity, which will be model trainer config is equal to name tuple of model trainer config. So this contains model name, index to tag, tag to index, tokenizer, XLMR config, and epochs, batch size, and save steps, and output directory. All this information will be taken from config.yaml file. Here we have this information. Once we get it, we just pass this information inside our component. The next step will be, once you create it, we have to connect both YAML file and this config entity using configuration file. So let's create our method. This will be get model trainer config, and let me write self here. So basically this model trainer config will have, so this is our model trainer config. If you see, we are just taking model name here. So let me put this YAML file aside so that it's easy to explain. If you see, we are taking the model name which is present here, base model config and the base model name. Once you get the model name, you just pass the same model name inside tokenizer. Here you just call auto tokenizer from pre-trained and the given model name. And we just extract all the tags which is present over here. For that, we just go inside processing key and then extract the tags, and we just follow the same step which we have followed over here. We just iterate through each and every tag and index, and we get the index here, and then here we get the tag. The next step is we are configuring. Let me close this, or let me move this aside. So the next step is we are just calling auto config, because we are creating a custom model which needs all the configuration from the pre-trained model. So we just call auto config dot from pre-trained, and this will take in the model name, and number of labels will be our seven labels. and the next step is index to label. This will be index to tag, which we have created over here. It is a dictionary, and then which will be, and then we call label to id. This will be tag to index. Let me close this. And the next step is epochs. For epochs, we just go inside the YAML file and take number of epochs, and as we saw in the YAML file, we just take the batch size and we take the save steps. All this information is now taken, which will be again passed into this model trainer config name tuple. And we also take the output directory where our weights will be stored. If you see here in config YAML, we have our path, and inside which we have our model weights. So let me see here. We are just calling os.path.join get cwd and the artifact key and model weight key. Once this configuration is created, we then return the model train config, and we just close this try block with except block. This will be custom exception. Now we have created our configuration which takes in the information. The next step is creating our component. So let's open component. So under component, let me create model trainer.py, and let me also create model architecture. So for model architecture, all you have to do is go inside our Jupyter notebook, and then we have created our architecture over here. Let me check. Yeah. So this is our model architecture. So let me just copy it and then paste it over here. So basically what we are doing here, we are just importing torch.nn, and then we are just importing XLM Roberta config, which contains the information of the Roberta model. And next we are just importing transformers modeling output. This will be token classifier output. You must have seen in Jupyter notebook why we import this, because it will give a proper output which contains loss, logits, hidden states and attention. And the next step is we are just calling model Roberta and the modeling Roberta. From that we are importing Roberta model as well as Roberta pre-trained. So this Roberta pre-trained contains the pre-trained weights, and Roberta model will have the model architecture alone. Now we import this Roberta pre-trained model inside this, and we inherit this in super.init. We inherit all the configuration from Roberta pre-trained model, and then we assign the number of labels, and we call the Roberta model here. This will have the pooling layer as false. I have explained you why we add pooling layer. And in the next step we call the dropout, which will have the config dropout probabilities. So it will be either 20% or 10%. And the next step we just call classifier nn.linear. This will have the hidden size and the number of labels, and then we initialize the weights here. Once all these steps are initialized, the next is we call the forward function, which will take in input IDs. Input IDs are nothing but input tokens, and attention mask will be given inside. So this attention mask is created by tokenizer. Next we create token type ID and label, and then we pass keyword argument. Once all this input is given, we just call outputs dot the model name and the input ID. Every input is given inside, and we get the output over here. And once you calculate the output, you just pass the output and get the logits out of it from the classifier, and then we calculate the loss. The loss will be nn.cross entropy loss, and the loss is calculated and passed into token classifier output loss here. And this token classifier output will be an object which contain all the required informations. Now that we have created model architecture, the next step is let's create model trainer. For that, let's import all the required libraries. Let's import exception, and let's import logger, and let's import config entity. This will be from entity, config entity, import model trainer config, and let's import from NER dot components. Now we have to import this model architecture inside trainer. So for that, we just call this model architecture and then import the class which is XLM Roberta token classifier. Next, let's import data collator from transformers. Import data collator for token classification. If you remember, we have used data collator to map the sequence. So for example, let me explain you how data collator works. So if you have a sequence of, imagine this is one sequence and this will be the max sequence. So the next will be, if you have some sequence which is lesser than the maximum sequence assigned, all this data collator will map it. So it will be something like this of different commas. If any sequence has lesser length than the maximum sequence length, it will just pad it. Let's import trainer. And I've imported other libraries. Now let's start creating the class. Which is train token classifier, and I'll just write the constructor which will take in model trainer config, and it will take in the processed data. Processed data will be dictionary. Now let's initialize it. We will create the first method which is create training argument. So for the first function, let's start by writing try block. Here we just log some information creating training arguments, and let's create logging steps. This will be logging steps for each and every points. So this will be basically logging steps while you train. So let me give it as self.process data, and this will have the train. So we just take the training data and then select the first 100 data points. Once you select it, we just divide it by batch size. So this will basically be like, if your batch size is 16, it will be like this. And in the next step, let's start creating a variable which is training argument. I think we have to import training arguments here. Now let's call it here training arguments, which will take in output directory. And for output directory, we have configured it in configuration. So let me call this as output directory, and log level can be error. We have to set certain parameters. So let me just copy and paste from Jupyter Notebook. So these are the training arguments which contain number of train epochs and batch size of training, batch size of evaluation, and save steps, and weight decay, and disable TQDM is false so that we can see the TQDM, and logging steps is given here. Push to hub is set as false. So the next step is, let's return this training argument, and let's close this try block. If there is any error, we can trace it as custom exception en_sys. So now we have created our training argument. The next step is, we have to initialize the model. For that, let's call model init. Here we just take the model name and then we call the config object and initialize it. As we are creating a custom model, we need to initialize the configuration which is already available from the pre-trained model. So let us call our custom model. This is the custom model which we have created, and then we just input from pre-trained, and here we can call model name, and config can be given as model trainer config dot xlmr config. If you remember, here we have just created the configuration. So I'm just basically passing this xlmr config which we have created in the configuration to here. So that's it. We can just close it. And in the next step, we can just call data collator. So data collator is a function which returns data collator for token classification object. So I have already explained you what data collator does. So let us call this class data collator for token classification, and then we call the configuration and tokenizer. We just input the tokenizer so that if there is any length of sequence, so that if there is any shorter sequence, it will be padded. And in the next step, we can create a method which is aligning our predictions. This will take in the predictions and labels and give out a readable format. So it is already created inside this Jupyter notebook. If you see here, so we will be doing the same now. Here we just call the predictions as np.argmax. This will take the maximum probability given to a class. So this will choose the maximum probability class. So let me call it as prediction and axis equal to true. And I'll call the batch size and sequence length. I'm just creating two lists. Now we will iterate through each and every predictions and then we assign the label to it and the prediction itself. So let me just close it, exception as E, raise the custom exception. If you remember here, I've already explained you why we choose -100 as the ID to mask the subwords. So if there is any word which is repeated again, see for example this is a word ID, for almost first 4 tokens it is the same word. So in this case we just assign the label ID to the first word of occurrence, and if the same word ID is repeated we just assign -100 so that it will be masked. Basically we are just masking subwords, and then we return a readable format of to list. Next let me call compute metrics. This will compute F1 metrics for our model. So this will basically evaluate the model and then generate the F1 score. We will just call ypred, ytrue. We will make use of this function which will align the prediction. Let's align it by self dot align predictions, and we can just give the prediction here. We just take label and the predictions from eval prediction. Let's return a dictionary which contains the F1 score. For F1 score we have to give ytrue and ypred. I think this should be F1 score, and that's it. Here we are just returning a dictionary which contains a F1 score for the prediction. Next let me call the final method which is train. This is the method which makes use of all the functions here and then initiate the training process. So let me write it as try block. Here we will log model training started, and we can create a variable called trainer. This will basically be trainer and it will take self dot model in it. This will be the function which we have created over here. Just call self here. Yes. Next let me give the arguments. Even for arguments we will be using this create training argument method. In the next step we are just calling data collator. Here again we will just call the method which we have already created, and for compute metrics again we will make use of this method. And now let's get the train dataset and the test dataset. Now we will make use of this process data which is passed inside the class. So I'll just copy this here, and in process data we have train. For now let's select only 100, or I can also select 60 for now. Let me change it even here, and we will just call eval dataset is equal to self dot process data. This should be validation. It's like there is some error. We can just give range of 10, and tokenizer will be self dot model trainer config dot tokenizer. Next let's log again, logger dot info. Trainer is running. Let me close it, and we will call the result is equal to trainer dot train and logger dot info. Result of training is result. So we are basically logging the result in the logs itself. And we will just call trainer.save. This will save the model. We can save the path also. Logger.info. Model is saved at self.modelTrainerConfig output directory. Let's close this, except exception as E, and that's it guys. This is the train function. So we are just calling this trainer class, and then we input all the information which is created over here. And also from our config, we are giving the tokenizer. Here from config, we are just taking the output directory where the weights will be saved. And this is it guys. This is the token classifier model trainer. And this is it guys. This is the model trainer component. Now the next step is, let's open demo.py and then run it to check if there is any error. If there is any error, we will solve it. So here what I've done is, I've just created a function where it checks the output of validate. If it is false, it will return false. If it is true, it will return true. So only if you have all three checks as true, the next process will be initiated. What we can do here is, now I have just imported this model trainer train token classifier as well as the configuration. So let me write it, and then we will initialize model training. Now I have just created a variable called as classifier and called the class train token classifier. Inside I have given the project config dot model train config. So I think this is get model trainer config. So we are just calling this configuration project config dot get model trainer config. This will give all the information from YAML file, and we are just passing the processed data from data pre-processing step, and this processing data will be trained. All you have to do is just start the training with demo.py. Let's activate the environment and let's start training by calling demo.py. This will basically be downloading the data now, and once it is downloaded, it will be validated, and after validation, data pre-processing will be started. This data pre-processing will give NER tags, input IDs, attention mask, and labels. Okay, so there is some small error. We will just go and fix it. This must be some typo error. It is model. So there is some error in model trainer. So it is saying, looks like there is a spelling mistake. So what we will do is, let's change everything. Let's change it as model trainer config. So we have changed it everywhere. Let's try to run it. So this might take some time, as it will download data and then process it. And yes guys, the training has completed. We have just trained for one epoch. As this might take lot of CUDA resource, I have just trained it for one epoch. Next, we will push all these changes to GitHub and then conclude this video. Let me add it. And let me create the commit, which will be, clear it, git commit -m, which is message. Let me write component 4 is added. Let's commit the change and then push it. Git push origin main. It's always a good practice to push all the changes to GitHub, because as you keep on pushing, you can have the code history as well. Looks like it is pushing the artifact also, so I just deleted it. And yes guys, we have pushed the changes to GitHub. In the next video, we will just create a new training pipeline. It will be similar to this demo.py, where you just call all this function and then initiate the pipeline, and it will be little bit modular than this demo.py. and after that we will be creating prediction pipeline. I'll meet you guys in the next video. Hey everyone, welcome back. In this video, we will start creating the training pipeline. Here, just like demo.py, we will be calling all the components and then run it. Let's start coding. Once you open your project folder, we have created a pipeline folder and we have __ init.py here. All you have to do is just create a new file called as train pipeline.py. So let's start importing the required libraries. We have to import everything which is inside the component. So let's call components dot data ingestion, import data ingestion. Okay, this should be from. Next, let's call NER.component dot data preparation. We just import data pre-processing. Next, let's import components dot data validation. Here we will be importing data validation. Next, let's import model training. Here we just write NER.component dot model trainer import model trainer. And I think next we will import configuration. So this should be configure. So let's import logger and exception now from NER.logger import logger from NER.exception import custom exception. Now that we have imported all the required libraries, let's start creating the class training pipeline. I'll call it as train pipeline. And let's write the constructor here as config and self.config is equal to config. And let's run the data ingestion. Here we just call self and then this will return a dictionary. So let's import typing and dictionary. From typing import dictionary, and we can also import list, and right now it's enough. So under data ingestion, we have to just call, I'll go to demo.py. We have to just call configuration and we have to call the data ingestion. Here we just give in the configuration as the input and then run the data ingestion. So let me run it here. First step is log some information. I'll be logging that running data ingestion in train pipeline. And let me call data ingestion as data ingestion. And here I will give data ingestion config as self.config.get. Okay. So here let us import the configuration. Now it's the data ingestion config. So this configuration will get the all the required information from YAML file. Next, let us run the data pipeline. Data is equal to data ingestion dot get data, and we will return data except exception as e, raise the custom exception. Next step, once data ingestion is completed, we will start data validation. So I will just call it as run data validation, and here I will just call self, and this will take the input of data itself. So we need data here to validate it. This will return a list of boolean. If you remember, this will return true, true, true in case the data is validated. If it is false, it will return false for the particular validation. So let me write the code here. Let's start with logger, and we just write logger.info. We'll write the same information, running data validation in train pipeline. So the next step is, let's call the validation. Validation is equal to data validation. Here the input will be data validation config. This can be taken from our configuration file, self.config.get data validation config. Next, let us call the checks. To start the data validation, let me call data validation dot drive checks. This will return the list of list which contains the boolean, and let us return the checks. Let's close this as exception as e. Now let us write the next component, which is run data preparation. You can also call it as data pre-processing. Right now I'll just call it as data preparation. This will return a dictionary. And let me write the try block here, try, and log the information logger.info. So information will be the same, running the data preprocessing in train pipeline. And here data preprocessing is equal to data preprocessing, and let's call the configuration inside. Data preprocessing config is equal to self.config dot get data preprocessing config. And I think here we have to give the data inside. This should be data, and same here, let me give input as data is equal to data. So processed data is equal to data preprocessing dot prepare data for fine tuning. Let me return the processed data. Except now let's write the next function, which is model training. So I'll just write run model training. This will take in self, and this will also take in the processed data. Let's log the information again, and let's call the classifier train token classifier. Okay, looks like I didn't import it. Yeah, let me call train token classifier here, and then call the model trainer config as self.config.get model training config. I hope it is model trainer config. And here process data is equal to the process data. Let us call classifier dot train. This will initiate the training, and logger dot info. Here let me call it as training completed. Now let us write the final function, which is run pipeline. So here let me call data is equal to self dot run data ingestion. So when you call this function, this will return the data. And next let us check the data here. Checks is equal to self dot run data validation. This will take in the data, and once we have to check if all these are true. So let me just see here, we have a function, so I can write this function here. So basically this is a function which will take in the check list, and it will check if any one step is false, it will return false. If all the steps are true, it will return true. So we are just checking that. If validate check checks, if it is true, we will start the step. So the next step is process data. Here we will just call self dot run data preparation. This will take in the data, which is nothing but our data. Next we will just import logger.info. We will write process data, and the last step will be initiating the training. So for that I will just call run model training. This will take in the process data. Process data is equal to process data. Else logger.error will write checks failed. So this is our training pipeline. Basically this is just like a demo.py. We just called everything inside a class, and then we created a final method which will initiate all these methods inside. So it is more modular. All you have to do is just import this class and then run this method. So this will initiate the training. And that's it guys. This is the training pipeline. In the next video, we will create prediction pipeline. Hey everyone, welcome back. In this video, we will be creating prediction pipeline. In prediction pipeline, we have to create a class which will take in the user input, and that user input will be converted into prediction tags. These tags are our NER tags. Now let's start coding. Let's open our project, and in the last video we have created the training pipeline, and it's better to log it. So what I will do, I will just push these changes to GitHub. Git add git commit -m train pipeline is added. Let's push it. So now we have pushed this training pipeline. Now let's start writing the prediction pipeline. Before creating the pipeline, let's create the entity as well as the configuration. Let's go inside entity, and here I will write prediction pipeline config. So this will be a name tuple which contains the informations like tokenizer, index to tag, tag to index, and tags. So let me write it. So these are the required information in prediction pipeline. We need tokenizer, truncation is set as true or false, is split into words is set as true or false, and output directory where the model is being saved, and index to tag and tag to index. So what we can do here is, let's go inside configuration and then create a method which will connect config YAML with config entity using this configuration. So let me write it as get model predict. So this is the method. Basically what we are doing here is, it's same as the trainer. Here we are just taking the tokenizer from pre-trained. We are taking the tokenizer name which is XLM Roberta, and truncation is taken from the config YAML. If you see here, truncation is true and split into words is also set into true. We are just taking that information from YAML file, and we are just taking the output directory which is nothing but where our model is stored. So we are just storing our model in the root folder, artifact key and the model weight key. So it will be stored inside this artifact and the model weights. Next step, we are just calling index to tag and tag to index, and we are just getting this information and it's been saved over here. We also require tags. So tags will be just tags. So probably we will be using this too or this. So I think we can just remove it for now. So let me remove this here, as well as I can go inside config entity and then remove this too. And I will add tags here. Now it's sorted out. We are just taking the number of tags, which is 7 tags, and we are just returning the prediction pipeline config. Now let's start writing the prediction pipeline. For that, let's go inside pipeline folder and then write prediction pipeline .py. Here we can just start importing the required libraries from NER.components.model architecture, import XLM Roberta for token classification. This is our custom model. We will be using our custom model to initialize the model. Next, let me call from ner.config.configuration import configuration. Next, let me use the exception. I think we can also import torch and import OS import sys. Let's start writing the class prediction pipeline, and let's initialize the constructor as this config, which will be our, we can just call this configuration here, and then we will just write config.get data model predict pipeline config. This will return the configuration. Next, let me import the tokenizer. Tokenizer is equal to config.self.prediction pipeline config.tokenizer. So this will have the tokenizer object. Next, let me get the tags for this. Tags is equal to self.prediction pipeline config.tags. So this will have the list of classes. So next, what we can do here is, if len of os.list dir self.prediction pipeline config.output directory is equal to 0, raise lookup error. So the lookup error will be model not found. Please run model trainer before prediction. You can just put like this. So if there is no model inside, it will raise the exception like model is not found. Please run the model trainer. And let me call the model now. Model will be our token classification custom model, and this will take in the pre-trained model name or path. Okay, let me call from pre-trained. This will take in the pre-trained model name or path. Here we can just give self.prediction pipeline config dot output directory. So we have just given the model name. Now let's create the first function, which is predict. This will take in the self. So let me write the try block. Inside try block, we will just write tokens is equal to, we will call the tokenizer self dot tokenizer And okay, here I should take in the text will be the input of user. So we just pass the text inside and then call tokens. Next, let me write input IDs is equal to self.tokenizer, and here I'll just give the text and return tensors is equal to pt, think it's correct, dot input IDs, and let's move it to CPU, and let us call output is equal to model, which is our model, and then this will take the input IDs, we will take the output here. Let me take in the prediction is equal to, basically this output will have the probabilities, we have to find argmax of it, outputs comma dimension is equal to 2, because we have 2 dimension here. Next, let me call the prediction as tags of p for p in prediction dot CPU, I'm just moving it to CPU dot numpy array. So this will basically be self dot tags. So we are just iterating through the prediction and we are just retrieving the tags for it. Next, let me filter the prediction. Filtered tags is equal to empty list and filtered preds is equal to empty list. Now let me iterate through each and every predictions. So this can be token and prediction in, let me zip both of this because this prediction and the token will be similar in length. So I'm just calling tokens and preds. So this will be 2 different lists. This will have different tokens, just like what you see in Jupyter Notebook. It will have many words which will be converted into tokens and thus respective subwords also. So we are just iterating inside to avoid the subwords here. If underscore in tokens, we are just checking if there is underscore. If you remember in our sentence piece tokenizer, you can clearly see the difference. Whichever word has some space between them, it will be starting with underscore. If there is no space, it will be, let me show you the example itself. Let me open the notebook. Here you can see that this is Jeff Dean. So there is underscore because I can see some underscore because these words contain space in between it. And if you go with this and it doesn't have the underscore. So in this case we will just avoid the words which is not having the underscore because most probably it will be the subwords. And let me write it as filtered tags dot append the token and filtered preds dot append the pred. Now we can just give out the filtered prediction itself. You can also remove this for now. Now let's close it with except exception as C. The last method will be run pipeline. Here I am just calling self and data, and prediction is equal to self dot predict. This will take in the data inside, and the next step will be response in the form of JSON. As we are creating fast API here, I am just using JSON as the output. Output data is data dot split and tags will be predictions. Now let's return the response, and that's it guys. This is the prediction pipeline. It will basically take in the text and that text will be passed to tokenizer so that it is converted into multiple tokens, and then we encode it with the tokenizer itself and then we give the text inside. This will return the tensors and we are just saving the tensors inside CPU. Next we call the outputs is equal to self.model. This will give the outputs which is nothing but the logits, and we are just calling tokens. Okay, this should be torch.argmax the outputs, and we are just getting the prediction by iterating through the predictions, and this is stored as a list. The next step what we are doing is we are just filtering out based on the underscore. Next we call a method. This is the final method which uses this and the data dot split. So this will return a JSON output. Now let us start creating the app.py. Again, you can just go inside the root folder of your project and then create app.py. Under app.py, all you have to do is just import fast API from fast API dot responses import JSON response. So before that, let me write fast API here and we will run it. New terminal, source activate env pip install -r requirement.txt. So this will install the left out fast API. Now let's close this and then create our application. Next, let me call fast API import fast API and requests import uvcon. I think we have to install uvcon. Let me add it over here. It should be added as first. Now I have installed both uvcon as well as fast API. So let's call the app is equal to fast API and then call it. Let's create our first route which will be app.route, and this can be the train route. You can just call train here requests and pipeline is equal to train pipeline. So here let us import training pipeline from NER.pipeline dot train pipeline import train pipeline. I think this is not access. So let me call the train pipeline, and inside this we have to give the configuration. So for that, let's import from NER.config.configuration import configuration. Let me call the configuration inside and then call pipeline dot run pipeline. So this will run the pipeline. Let's return the JSON response as content is equal to training completed, and status code can be given as 200. Let me just write it as status code except exception as E, and then raise the JSON response. Here we can just give the content as error while training pipeline and status will be 500. Next, let me call app.route. This is our second route which will be nothing but our prediction pipeline. So this prediction pipeline will just take in, this will take in the data, and let me write try pipeline is equal to predict pipeline. So we have to import that from ner.pipeline. Here let me write it as prediction pipeline import prediction pipeline. Okay, so this can be given here. Config is equal to configuration and data will be data. Let me call run pipeline here. This will run the entire prediction pipeline. Let us give the response as, so here I will store it as response JSON response, and content is prediction. No, content is our response and status code is 200. Except exception as E, raise the JSON response. I'll just give error here. Error can be given inside a dictionary which is string of E. We will just post this exception inside this so that in the application you can see status code is 500. So I will just do the same here and let me close the dictionary. Next, let's write if underscore underscore name is equal to main uvcon dot run the app which is created over here, and then host will be in strings and port is 8080. And that's it guys. This is our application. Next, let us test our application. Let's activate our environment and let's run python app.py. So you will get some security alert. Just give allow access. So this should be 8080. As we don't have any front end, you have to access this using docs. So looks like there is some error. I think I found it out. It should be app.post. It should not be route. Let me rerun it. Now it will be working. And yes guys, now you can see that. So this will be the fast API of your application. This API you can test it by just going to the predict and then click on try it out, and here you just give the data. So for data we will just go. So let me just copy this and then paste it here. Let's run it. Okay, there is some error, internal server error. So this is an error here. Instead I just give error here. Okay, looks like, and even here I just give error. Let's rerun it. Let's click on try it out and then paste the text. Okay, looks like there is some error again. So here under prediction pipeline we have an error. The error should be pipeline got unexpected data. Now I should not give it here. It should be given data is equal to data. Let's rerun it and check if it is working. Looks like now it will work and we will get the output here. And yes guys, here I just gave the tokenizer name. So what we can do here is just go inside prediction pipeline, and then here we have just taken the tokenizer name. So let us just initialize it. So for that, let's call auto tokenizer. From transformers import auto tokenizer, and let me just call it over here from pre-trained and then this tokenizer. Now let us just close this app and then rerun it. Okay, looks like we got the output. You can see here the dog was called Wellington. So Wellington is called as a person, and here Mr. Mrs. is called as a beginning of person, and Shears is called as inside of person. So it is predicting accurately. Let me just, we will be testing with another text. So this should give even better results. Let us check here. And it has clearly mentioned as lorem ipsum as a organization, and the final two words is taken as beginning of person and inside of person. So it is working perfectly, and that's it guys. This is your application. Next, all you have to do is just create a Docker file and try to run it locally. Once it is successfully run locally, we will just push that Docker file to AWS EC2 machine. Now I will just meet you guys in the next video where we will be creating the Docker file. Hey everyone, welcome back. In this video, we will be creating Docker file for our project. So what is Docker? Docker is a tool that helps you to run the project in a container. So container, it is a kind of box which contains all the required informations for our project to run. So by using this Docker, we can run our project in any computer without having to worry about the right setup. Initially, if you remember, we have done some environment setup where we install all the dependencies. So in case of Docker, there is no need to worry about it. All you have to do is just create a Docker container with all the packages installed. For example, let's say you want to run a simple machine learning project which requires Python 3.10, PyTorch and other dependencies. You can create a Docker container that contains the necessary files, settings and all the dependencies for this project. So in this case, all you have to do is just run this container on any computer and it will be running just like how it ran in your computer. So it makes it easy to run in multiple machines. That's why we use Docker. You can download Docker from this website. You can just click on this download Docker desktop. It will download the app. I've already installed it. Make sure you install this before watching this video. Now let's open our project. This is our project root folder. Just open this and then create a file called as docker d capital docker file. So this will be automatically recognized as our Docker file. Now let's start writing our Docker file. Let's write from Python 3.10 Slim Buster. Next step will be copy this to name entity recognition should be on. So here what we are doing is we are just copying all the files from our root folder to name entity recognition. So all the file means all the files which are tracked by Docker. Even for Docker we have some file called as Docker ignore. So let us create it. So Docker ignore will untrack all the files which are not required to be put into the Docker image. So some files includes artifacts. Let's remove this artifact. We can also remove env, logs, and I think notebooks is also not required, and git ignore is also not required. Readme.md and demo.py license is also not required. So now this will copy all the file which are not inside this Docker ignore to the two newly created name entity recognition folder. So the next step is create the working directory. So working directory can be this name entity recognition which we already created. Next, let's install pip install upgrade pip. So here we are just upgrading the pip to the latest version so that it won't have any issue while installing the dependencies. So the next run command will be pip install -r requirements.txt. So this is a command which we will be using just to install all the packages which have been mentioned inside this requirement.txt. We do the same so that all the libraries will be installed in this Docker image. And let me write cmd. So this will run the command python app.py. So this is the final command which will run so that our application will be initiated. Okay, let's close this. So this is our Docker file. Next, let's start building our Docker image. For that, let's open the Docker desktop. So our Docker desktop is starting. Now we have opened our Docker desktop. This is how it looks. Here you can find my old containers and here you can find my old images. Now all you have to do is just minimize it and open our terminal. Once you open your terminal, just write docker and check if it is installed. You can see that it is working and it is installed. Next, let's write docker build -t. Our image name can be NER dot. When you give this docker build -t your image name and dot, which means it will create Docker image based on the current working directory. Now this command will go to this Docker file and check all this command which we have written. Based on this it will be created. You can see that it has created a new working directory called as name entity recognition based on what we have given here. Now once it is installed, the next step is we have to run the container. Let's wait until it creates the image. Now it has installed all the required libraries and it is exporting the image and exporting it in layers. And yes guys, Docker image is now created. Let us check here. Inside image you can see that we have created the Docker image. Next, we have to run this container. So for that, let's go here and then if you click on run, it will run. Let me show you in command line itself. Let us clear this and write docker run and you can copy the image tag from here. Let's copy this. Let me port map it to 5000 8080. Run -p will port map it 5000 to 8080. Let's click on run. You can see that it is running in container now. Let this command line. Okay, there is no model called as SQL. Okay, let's install it. For that you have to remove this Docker image. Looks like I didn't add it inside the containers. So let's delete this container and go to image and then delete this image. Okay, there was some issue with my RAM. Let's open requirement.txt. Here you can just give SQL which is missing inside the Docker. Let me give this and then rerun docker. Let me clear it. docker build -t. The tag is NER and current working directory. Let's run it. So this will create the Docker image again with SQL installed. So I'll meet you guys once it is installed. And yes guys, Docker image is created. You can see that it is around 6 GB and it is created here. You can just click on this run and then start it, or else you can just write docker run -p and you can port map our map as 8080 5000 colon 8080 and then give this image ID. So let me run it here. Just run docker run. Let me give it as 5000 if you want 8080, or this can also be 8080. It should be -p 8080 and the image ID. So this will run the container and you can check it in the background. So this is our, just go on Flask and just open the 8080 localhost slash docs. Now you can see that our Docker image is successfully running. So this is our application up and running in the Docker image. It is a container now. Now all you have to do is just take this Docker file and then give it to CI/CD pipeline, where it will build the image, and that built image will be pushed into AWS EC2 or GCP, where you can deploy your project. And to summarize this video, we have just created a Docker file which contains from this will be the base image of our project, and here we have just created a folder inside the Docker image, and this is called as name entity recognition, and we have just made it as working directory. Next we just run upgrade pip to upgrade the pip, and the next line we are just running pip install -r requirement.txt, which will install all the required libraries from our requirement.txt file. Next we are just running command which is python app.py, which will initiate our application. And that's it guys. In this video we have created a Docker file and it is successfully running. From next video we will create a workflow file where we will create the workflows for CI/CD pipeline, and we will be using GitHub Actions to push our Docker file to AWS EC2 machine. Let's meet in the next video.
Hi everyone, my name is Ketan, and in the last video we have seen how to create user and how to give permission to the user. Now in this video we will see how to use that user to log into AWS account. So first what you need to do is log into your main account, that is root user. Provide a password to it. Once you do it, you will see AWS Management Console. Now again go to IAM, that is Identity and Access Management Service. On IAM you can see that at the right hand side there is account ID. Just copy the account ID. Now just sign out from the system. Now just click on sign in to the console. Now this time select IAM user. Now here you need to paste this ID that you have just copied. Click next. Once you have done it, give the username that you have given while creating the user. For me it is K10. Now give the password. Password is hello@123. Now once you provide the access to it, it will log into the AWS Management Console. Now here one thing you need to notice is, in the last video we have given total 4 service access to this user, that is S3 bucket, RDS, EC2 and ECR. Apart from that, this user can't access anything. To check it, just write code commit here. This is one of the service of AWS. If you click on code commit, you will see an error message saying that this user doesn't have access to this, access denied exception, right? Which means that we can't access the service because we don't have permission for it. Now if you want this user to have permission to code commit, you need to go to the main account, that is root user account, give the permission to this user, and this user will be able to access it. So this is how you need to log into the system using the user that you have just recently created. Thank you. I'll see you in the next video.
Hi everyone, my name is Ketan and today I will show you how to create an user on AWS Cloud. For this, you require AWS Cloud with the payment process completed. So once you complete the payment process, you will navigate to AWS console home as you can see on the screen. So to create a user, we will mostly be working with IAM service of AWS, that is Identity and Access Management. To navigate to this service, you have two possible ways. One is this service tab at the top or the search bar. So just write IAM in the search bar. As you can see on the screen, you will get all the services that are related to IAM, but we are most interested in IAM manage access to AWS resources. Just click on this service. Once you click on this service, AWS will navigate you to IAM management console. On the left hand side, you can see access management and access reports. We will work with under access management users. So just click on the users. On the screen, you can see a lot of users are present, but for you, it will be empty because you haven't created any user yet. So just to create a user, just on the right hand side, click on this blue button, add users. Once you click on the button add user, AWS will prompt you to with the some details, that is user details and AWS access type. So in the users detail, just give username to your newly created user. For me, it's K10. Select AWS access type. In AWS access type, there are two ways to access AWS. One is the programmatic access and other is the management console access. So programmatic access is by AWS CLI we can access the services. Management console access is what we are doing right now. So just check both the boxes. Once you click the AWS management console access, you can see console password and require reset. So I will go with the custom password. You can also click on auto generated password, but right now we will go with the custom password. Just click here, just give a password to it. I will write hello at the rate 123 and then require password reset. So what you can do is, if you want to reset the password on the next login, you can check it, but right now we don't want to reset the password on the next login, so we will uncheck it. Click on the next permission tab on the bottom, you can see. So once you click the permissions tab, AWS will prompt you what permissions you want to attach with this user. So what I mean by this is whether this user can access EC2 machine or whether this user can access code commit or not. For us, right now we will not attach any permissions to it, but you can then add it by directly clicking it here. So just go to next tab, next tags. Under tags, you can provide additional information to the user, or you can attach some information that is necessary for your organization to put. For me, I'm writing team, that is machine learning engineer, MLE. Now just click on the review tag. Once you click on the review tab, what will happen is AWS will prompt you with the user interface where it is giving you a warning that you can see on the top. This user has no permission, which is perfect because we haven't attached any permissions to it. So just keep it as it is. Just check whether we have programmatic access and management control access where we require password reset or not. And permission boundary, we haven't given any permission boundary to it. Just click on the create user. Once you click on the create user, you will navigate to page where you can download all the credentials for programmatic access, that is access key ID and secret key. Don't share it with anybody because with the help of this credentials, someone can access it programmatically. So just download the CSV here. Just click the download button. Once you click the download button, it will download to your in your machine. It will download the credentials and then just click on the close button. So once you click the close button, you can see in the here K10 user is created with no permission, and this user hasn't accessed it. So it's saying that never access this AWS management console. So I hope today you have learned how to create a user on AWS. Thank you and have a nice day. Hi everyone, welcome back to the video. In this video, I will show you how to attach permissions to the user that we have recently created in the last video. So for it, just log into your AWS account. Once you log into your AWS account, you will get AWS management console as you can see on the screen. For it, what you need to do is first navigate to IAM service, that is Identity and Access Management. Click the tab. Once you click on it, AWS will navigate you to IAM Management Console. As you can see here, on the left hand side, there are two services. There are two tabs: Access Management, Access Report. Click on the Access Management here. under which you have users. Click on the users. Once you click on the users, right now you will be having only one user, but to navigate to the user, just write K10. That is my username. You can also type your username here. So just navigate to the user. Once you click on the user, you will have an interface like this where you can see permissions, group, tags, security credentials, access advisor. I want you to click on this permission tab. Right now there is no permission policy attached to it. To attach permissions and policies, you need to click here, add permission. As you can see on the screen, this tab is similar to the last video where I told you to skip it. Right now what we will do is we'll list down all the services that we want this user to access. So for it, just let's navigate to attach existing policy. As you can see on the screen, once you are here, you can see all the policies already created by AWS, but there is a way with which we can also create our policy and attach permission to the user. Right now, let's see all the policies that AWS has created for it. For us, we have administration access, we have Alexa for business. A lot of policies are here. To navigate to the service that you want your user to access, just write the service name here. For me, I just want to access S3 bucket. So you can see that Amazon S3 full access. Just click this checkbox. Similarly, I want to attach RDS, that is relational database services. Write RDS here. Now you can see Amazon RDS full access. Just give this to the user. Similarly, I want to access Elastic Cloud Compute, that is EC2. So just write EC2 here. You can see Amazon EC2 full access. Check this box. Now there is one more permission that I want to give it to the user, but that that policy has to be created first, and then only we can attach it. That is Elastic Container Registry. Right now this policy is created by me. There is no symbol by Amazon, you can see. But what I'll do is I'll show you how to create it. So just right now we'll attach all the three services that we have selected. Click on the next button. Now you can see all the three services that we have selected. That is S3 full access, RDS full access, EC2 full access. Just click on the add permission button. You can see. Once you click on the add permission button, you can see all the three permissions are directly attached to the user. Username is present here. All the permission that we have right now attached is present here. If you want, you can also remove it by clicking this cross button. And if you click on this deattach button, it will remove the permission from the user. But right now we will not do it. Now as I told you, I also want to attach one permission, that is ECR, Elastic Container Registry. For it, what you need to do is go to policies. Once you click on the policy, you can create your own policy. Click on this create policy button. Choose a service for which you want to make a policy and you want to attach that policy to the user. What I want is Elastic Container Registry. So here I will search Elastic. Here you can see Elastic Container Registry. So I will click on this Elastic Container Registry. I want to give full access to the Elastic Container Registry. So what I will do is I will click this checkbox. Now here you can see resources. Just click on the resources. And in this account, in this account, click this checkbox. Just click on the next text. Now here you can provide additional information, but then it is not necessary. Click on next and review. Now here you have to give a name to the policy that you have just created. So what I will do is I will give Elastic Container Registry. If you want to give any additional description to it, you can give it. I will say created by K10 to access ECR. Just create a policy. In this button you can click. Once you click this policy will be created and you can see it in the policies tab. So on the left hand side you can see access management, policies. Under policy, just whatever name that you have given, just search it. Elastic Container Registry, can you see there are two policies? It was previously created by one of my teammate. So this is what we have created, because you can see here used as permission policy, but we haven't used it anywhere, right? So what we will do is, here you can see that created by K10 and V17. Here you can see created by K10. So this will help you to navigate the description. If you have the same name for the policy, just click on this container registry policy, and then you can list all the things that it can do. All the things are present here, as you can see. Now what we will do is, we will attach this policy to the user so that user can access ECR, that is Elastic Container Registry. So go to users, search your user here, click on the username, click on the add permission tab, go to attach policies directly. Here search the name that you have given, that is Elastic. Now you can see on the screen we can see Elastic Container Registry. Just select that you have created, used as none right now. Click on next review. Now we are saying that it's a managed policy because we have created it. Add this permission to the user. So right now, if you can see, we have attached 4 permissions to the user, that is EC2 full access, RDS full access, S3 full access, and Elastic Container Registry full access. In this video, we have learned how to attach permissions to the user. Thank you and have a nice day. Hi everyone, my name is Ketan, and today in this video, we will learn how to create Elastic Container Registry on AWS account. So what you need is AWS account. Once you log into your AWS account, you will see a console like this, and you can see this is AWS Management Console. Now there are 2 ways to navigate to Elastic Container Registry, is by one clicking on the service tab or by typing it here. So I will type it here. Now as you can see on the top, we can see Elastic Container Registry, that is fully managed Docker container registry. Now with the name, I hope it is clear that we can store our images here. So once you log in first, or once you navigate to this service, you will see an interface like this, and here it is everything is written as a short note. What it is, write the code, Amazon ECR, and what all things you can do with it. It is also showing some connection with ECS and EKS, which is higher advanced topics in AWS, but all these things are possible. Now to create your own repository, what you need to do is just click on get started. Once you click on that get started button, you will navigate to this page. Here you can see general settings, image scan settings, encryption settings. So just click on general settings first. Here you can see visibility settings. So when we are creating any repository that is private to our organization, we will keep it as a private. There is a option where you can select public, but once you create the repository, you can't make it private again. So you need to be very sure what you are doing. I will go with the private. And if you want to know more about this visibility settings, you can click on this info. A tab will open. Here it is saying that the visibility settings determines whether your repository will be public or private. Then you have to give a repository name. So as of now, I will give it as a production. So whatever name feels good for you, you can select it according to your organization. Now you need to see this tag immutability. So this is self-explanatory. Let me read it. Enable tag immutability to prevent image tags from being overwritten by subsequent image pushes. So what it is saying is, it is saying that if you have already image present in this repository with the same tag, if you enable this button, you can't push with the same tag. So you have to change the name. So if you keep it disabled, you can push it. Here it is written, the tag immutable setting determines whether the image tags in the repository can be overwritten. So let's keep it disabled. And now you have image scan settings. When you are pushing image to the Elastic Container Registry, you can scan those images at that time. If you want, you can enable this setting or keep it disabled. You have encryption settings if you want to encrypt anything. Now, once all these things are present here, once you have properly seen all the configurations, just click on this create button, create repository. Now you have your own private repository on Amazon on which you can send your images. So if you just click on this, Now, as of now, there is no image, but when we connect it with our CI/CD pipeline, you will be able to send images over it. Thank you. Hi everyone, my name is Ketan, and today I will show you how you can create virtual server on AWS cloud. For it, you need an account with the payment process completed. Once you complete the payment process, AWS will navigate you to AWS Management Console, as you can see on the screen. Now, since EC2 is a service of AWS, there are two ways to navigate to it. One is by just clicking on the service tab, as you can see, or by searching it in the search bar. So we will first search in the search bar. Now you can see all the services that are related to EC2. We are interested in virtual server in the cloud. Click here. Now you can see the dashboard of EC2, where you have a lot of information present on the dashboard about resources, launch instance, service health, scheduled events, migrate a server, explore AWS, account attributes. So these all informations are available with you. But right now, whatever information we are seeing, it's specific to North Virginia region, since we are in North Virginia. But if you want to see the global information, you can just click on this tab saying that EC2 global view. Just click on it and AWS will navigate you to global view of EC2 machines. There you can find that we have total 17 regions that are enabled, and we have 66 subnets and all the specific informations that you would like to see. Now let's go back to our main North Virginia region. Now on the left hand side, you can see we have lot of information regarding instances, images, elastic block storage, network security, load balancing, auto scaling. So in under instances, if you go, you will see what all instances right now present in your North Virginia console of EC2. What are the instance types that are available? If you click here, you can see a overview of what all types are present. Right now it's loading. Let's wait and let's see what all types are present. Now you can see all the types that are present here. We have T2 micro, nano, then T1 micro, T2 nano, T2 small, T2 medium, T2 large, and then what memory you will get and the pricing. So all this information you can see and navigate from here. All the information is present over here. Please select it according to your organization need. We have launch templates. In launch templates, we can write what kind of configuration we want to launch. Here we can define everything as a template. We'll talk more about it. Then we have spot request, saving plans, reserved instances, dedicated host, capacity reservations, etc. Now, if you see, we have under images, we have AMI, which stands for Amazon Machine Images, or Amazon Machine Image Catalogs. So if I click on catalog, you can see all the images that are available with us, and we can directly use those images to launch machine. From here, we will be using Ubuntu, that I will show you while I create each instance. Now on the left hand side, you can see elastic block store. There we can see volumes, how much volume any EC2 machine is using. Right now I had one machine, MLflow server, that is using volume of 50 GB. It's arbitrary, you can assign whatever you feel like and what is your requirement in the industry. Accordingly, you can select. You can always take a snapshot of the system that you are working in, so that configuration is also available, and then lifecycle manager is also there. We have network and security. Elastic IP we can attach, since if you are launching any machines, the public API of the machine will change if you restart the machine or stop and start machine again. But when you want a static IP of the machine, you can always go ahead with the elastic IP. We have security groups related to what ports we want to open in the machine. We have key pairs, which allow secure connection to with our machine. We have load balancing if you want to scale that machine. That options are also available. And if you want to write auto scaling templates, launch configurations, you can write it here. So this was the overview of how we can create, or what all options we have with EC2. Now let's go and create our EC2 machine. Go to instances. Now on the right hand side top, you can see launch instances button. Just click here. Now, once you click that button, AWS will navigate you to EC2 Management Console under Launch an Instance. Now, there are a lot of informations will be required for you to put. We'll go one by one. So, it is asking you to give a name to the machine. You can give any name to the machine. It's arbitrary. It's not fixed. You can give according to your use case. Right now, what we will do is we'll say sample EC2. Now it's asking you to select application and OS image. So that is Amazon machine image. So there are bunch of things available with you. You can always go ahead with Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, and all the Debian environment you have. This is basically the OS. Now for this particular video, let's go ahead with the Ubuntu. Now there are different types available with Ubuntu. You can select according to your need. We have 2022.04 LTS, that is Jammy version. 2004. Again, we have all the configurations. Now here you can see deep learning AMI GPU PyTorch enabled and the version of the PyTorch. So for deep learning, they have done some configurations in the OS itself and they have stored it. So for the machine learning or deep learning requirements, you can select it. But for our video, we can go ahead with the Ubuntu server 2022.04 LTS. Now here you can select the architecture. I would say go ahead with the 64-bit cross 86. Now here in the instance type, you can select what kind of base machine you want. It means how many number of CPUs you want and how many GPUs you want in the memory. Once you select this type of machine, let's go and click it. So there are different types available. For us, free tier is 1 vCPU, that is 1 core CPU, and 1 GB memory will be available. So let's take little bit big machine. Let's go ahead with 2 vCPU and 4 GB memory. But for use cases, according to use cases, you need to select for your organization. So let's go ahead with the T2 medium as of now. Now we need to select key pair. Here you can see you can use key pair to securely connect to your instance. So always if you have other pairs, you can select it, but we will create a new key pair. Now this you have to keep as a secret. So I will give sample EC2. Just select private key file as a PEM. Don't select it PPK. Just keep it as a PEM and create key pair. Once you click it, it will download it in your system. Then we have some network settings. Now in network settings in the firewall, you can always create security group or you can select existing security groups. So if I click on here, I can see all the launch wizards are present. By default, you can see default will be present in your machine. You can see default one. Either you can go ahead with the default or you can create your own. When you create your own security group, you can see launch wizard 5, 6, 7 according to the number of times that you are creating. But let's go ahead with the default one as of now. Now configure storage. So how much storage you want as a base for this machine? Let's select it as a 15. You can keep it 8, no worries. Now there are some advanced options saying that do you want to give a purchasing option like request spot instances, shutdown behavior, like if your machine goes off, what should it do, stop, hibernate behavior, all the behavioral you can control from here. And at the bottom if you go, it has a user data on start, what scripts to run. Right now it's not required for us, so we will not go in depth in advanced details. But on the right hand side you can see software image Conical Ubuntu 2204. This is the base image that we are using, that is AMI. We are using T2 medium, firewall default, storage 1 volume, 15 GB. Now if you click on this launch button, it will launch the machine. Now once you click on the launch button, you will get this success message saying that you have successfully launched the instance. Now just click on this instance and AWS will navigate you to EC2 instances tab. Here you can see. Now just cancel it and you can see all the machines that are present, and you can just measure the state of the machine that is pending right now, and in some time it will be converted to start or running. Now let's just wait for the state when it becomes running. Now you can see here your public IP, private IP. You can see instance details here. You can see security details. Networking you can see from here. Storage, status you can check. Monitoring, it provides automatic monitoring of CPU utilization, status check. Everything will be there. Now if you can see here, the instance has become running now. Instance state has become running now. Now let's connect to this instance. If you click this button, EC2 will show you how you can connect with your machine. So there are a couple of ways you can do SSH. You can create session manager, EC2 serial console. But we will go with the EC2 instance connect. Just directly click on the connect button and it will pop up a new window where you can see your machine. So let's wait for the machine to start. Now as you can see here, our machine has been started now. In this video, we learned how to create EC2 machine on AWS and how to launch our virtual server. Thank you and have a nice day.
Hello everyone, welcome back. In this video, we'll see how to run the Docker Compose file. So before we go into Docker Compose file, so there were some modifications which had to be done for our main Docker file. So these changes were like very simple, like we just had to update and then install unzip. So we had, as usual, we upgraded pip. So we installed torch using the CPU version, and the other requirements also were installed. So the command was to run python app.py. So coming to the compose file, so we'll be using the third version of compose. So the services will be application. So the application service will use the image, this image name, it's a environment variable. So we will now build the Docker image and then export the name as environment variable. So these will be the port mappings. So 8080 to 8080. So as we know, our app runs on 8080 port. So this is 8080 port. So coming to the Docker file, so let's build this Docker file. So we'll do docker build -t and let's name the image name to be test. So that's fine, and dot and then enter. So this might take some time to install, so let's wait till then. As you can see, the Docker image has been built successfully. So now let's export the environment variable. So export. So the name was image name. So let's put image name equals to, and I'll put the image name was test. So enter. So to run the Docker Compose file, so we need to just use a simple command. So Docker Compose up like that. Yeah. So it's creating the network. So it's running the container. So let's wait. Okay, as you can see, the application is running at 8000 baud. So let me go to this service. So let me bring that here. Hope you are able to see the screen. So localhost at 8080. So add /docs. As you can see, we are in docs directory. So we have already trained the model. So we'll go to predict route. So click on try it out. So we'll get the training data. So let me get one prediction itself. So let's take this. So take this sentence, just paste this here and just click on execute. So in the backend, we'll see what is happening. So in the backend, so the model is getting downloaded. So we can see the code for downloading the model is here. So this model is directly present in Google Drive. So and this is the key ID. So if you want to download the models from Google Drive, so you can use this gdown and you can pass in this ID. The ID is this. So we are then it will get downloaded as a zip file. So we are unzipping it. So the output path will be /artifacts.zip directory. So yeah, that is the thing. So let's wait till then. As you can see, the model is downloaded, so it's inflating. So the zip file got downloaded, so it's unzipping it. So yeah, so it started that. So it's downloading the config.json. So sentence space model. Okay, and it gave me a successful 200 response, you can see. So let me have a look on that. So as you can see, yeah. So hope you're able to see the screen. Yeah. So we can got a so under text point. So for this was the sentence input data which we are given. So and these are the tags. So the NER tags you can see. So let me zoom in a little bit again. So yeah, this is better. So this is the input data which we are given, and this is the tag. So beeper, iper, so o, borg, iorg. So yeah. So this was it from the local part. So next in the next video we'll see how to deploy this in GitHub Actions. So via GitHub Actions in AWS itself. So yeah, thank you. Hello everyone, welcome back. In this video, we'll see how to deploy our application using GitHub Actions. So the name of the workflow will be deploy application Docker image to EC2 instance. It will run on the events of workflow dispatch. So the jobs being continuous integration. It runs on the Ubuntu latest image. So the steps are to check out the code, configure the AWS credentials. So these will be the AWS credentials. So log into ECR. So and then build and tag the image, build, tag and push the image to ECR. So this will be the ECR repository name, and the image tag will be latest. So we'll build the image and we'll push the image. So next job is continuous deployment. So it needs the continuous integration job. It runs on the self-hosted runner. So I have already configured and set up the self-hosted runner. So I'll show you in a bit. Okay, then next is check out the code. So next is again to configure AWS credentials, same AWS credentials, same login to ECR, and then in the pull the latest image. So this will be the ECR repository name, which will pull our images from. So we'll run docker pull, and the repository name tag will be again latest image. So we'll set the environment variable and start the Docker container. So the environment name will be image, like you in Docker Compose file, the application image name needs to be set as the environment variable. So this environment variable is being set here in GitHub Action. So the image name will be secret repository name, and then we need to run the command docker compose up -d. So -d stands for detach mode. So it will be running in the background itself. And then next is to clean up the old images in the container. So we'll use docker system prune -f. So it will delete all the previous old images itself. So yeah, so this was it about the docker GitHub workflow. So now we will see how the GitHub runner setup. So what I have done is, so I have already set up the runner. So in here I have installed Docker also. So let me show that to you. So let me zoom in. So if I show you Docker ps-a, Docker ps-a. So Docker is already running in my system. So that's good. So if you don't have steps to like install Docker, so I have provided scripts here in this. So in this directory there is a scripts folder. So here you can see steps to install a Docker. So you can just copy paste these commands, and then Docker compose and Docker will be installed in your system. So that was about the Docker. So runner is also running. So let me prove that to you. So let me bring up that repository. So I can so yeah, not this one. So yeah, this one. Yeah. So as you can see, the self-hosted runner is in idle condition. So let me zoom this. So it's ideal. So it means that it is already running. So I have already configured this. So let me run the workflow itself. So in order to run the workflow, you can go to actions. Let me zoom this. So you can go to actions. So you can see here all workflows. So there's a deploy application image. So there's something called a button run workflow. So just click on this run workflow button, and the workflow run was successfully requested. So let's go here. So let's deploy this. Continuous integration job is running. So the continuous integration building the image. So before let this be process done. So in the meanwhile I'll show you how to set up the credentials. I'll show you the credentials part. So let's go to secrets and variables actions. So this will be the AWS access key ID. So you need to just set it up. So the default region, the secret access, and the ECR repo. So I've seen many people who make this mistake. So in order to prevent that mistake, so what you need to do is, so go to ECR. So you can go to your repositories, and if you can create a new repository. So let me zoom this. So you just need to copy this part of the URI itself. So just click on this button, and then like come here, just click here and update the value itself. So and just paste this value like this, and it's done. So no need to do any other further changes. So for now the secret is the same, so I'll not update it again. So let's go back to the other secrets. So the other secrets is the same, default region, AWS access ID key. So that's the same. So go to actions, run the, so continuous integration is running. It's building the image. Okay, that's good. So it's already pushed. Okay, so let's wait till then. Okay, so as you can see, the image got pushed. Okay, so it's always a continuous integration job ran successfully. So we are waiting for deployment to happen. So in the meantime, we'll see, I'll show you the ECR repo itself. So let me zoom out a little bit. So if you can go here and just see, you can see at this timestamp, which was today itself. So the image got pushed, which is latest tag. So yeah, so coming to the, okay, so here continuous deployment job, AWS credentials got configured, login is done, it's pulling the latest image. So yeah, so its download is almost complete. Let's wait. So it's setting the environment variable and it's running the container. Okay, that's good. So it's almost done. So as you can see, like Docker Compose app is done. So and you can see blue ticks are there here, so we can deploy the application. So the deployment is successful, as you can see. So there are green ticks here. So let's go to the public, get the public URL. So in order to get the public URL, so we need just go back here. Go to his EC2 instance. So my EC2 instance name is NER PyTorch. So we'll look on the, grab this. So we'll get the public IP. The public IP is this one. So just copy this and paste with 8080 port. So I have allowed 8080 port to in the EC2 instance configuration. So we'll go to /docs directory. And as we can see, the fast API docs is coming. So we'll do a sample prediction the same way which we did last time. So just click on try it out and give the sample test data. So the sample test data being, so this one. Yeah, just copy this. Yeah, just copy this. Sorry, get this not. So copy this and then just click on execute. So just let's wait for some time because the model, as we in this previous video also we saw, like the installation of model takes time. So let's wait. So as we can see, the success prediction is being successfully given. So we can see that the input data has been given here. So we can see the tags also. So let me zoom this a little bit more. So you can see. So input data. So this is the tags beeper, hyper, and then borg, iorg. So this was it about the prediction itself. So you can use this API to it again and again. So yeah. So before we go back, so we need to delete all the EC2 instances, everything which we created. So let me close this for now. So in order to delete the EC2 instance, go to instances, select the EC2 instance which you created, click on instance state and then click on terminate. So the terminate, it will be terminated. So just wait for some time. So in the meantime, we'll see about the NER image repository. So we'll just click here, delete this, click on delete, and the image is also deleted now so that you don't get charged for storage and all that. So we'll delete the repository also. Repository also is not needed. So let's delete this also. Delete this also. You deleted the repository also. So no repositories here. So EC2 instance. EC2 instance is also terminated. So coming back to GitHub Actions. So this was GitHub. So let's go to Actions, Runners. So you can see this offline. The runner is in offline status because we removed the EC2 instance. So we'll click this button. 3 dots are there. Click this. Remove runner. And let's give my password. Yes, force remove this runner. And the runner is successfully deleted. So no new runners are there. So yeah. So this was it. So anything else we left it? So no, I guess. So So AWS console is there. Nice. Okay, fine. So yeah. So coming to code wise, yeah. Yeah. So this was it from this video itself. So thank you.
Hey everyone, welcome to a last and final video for this project. Here we will see the conclusion for this NER using PyTorch project. In this, we have demonstrated how to train and load a custom NER model using extreme dataset. And here we have used Roberta transformer architecture. So we have used Hugging Face library to easily load and process the data and also to train the model. We also deploy this model using Fast API, and this Fast API application is containerized inside Docker. This Docker image is being pushed to EC2 machine. And we also saw that this solution can be applied in many industrial use cases. We will be using it for search engine recommendation systems and content classification and customer support, research paper screening, and also for resume parsing. Overall, this project will provide you a simple and effective solution for training and deploying a NER model, and you would also learn about how to use transformer library for this custom task of NER. We have completed our project, and for you guys I have just given 3 assignments. In this assignment you have to select any NER project from iNeuron internship platform and you have to submit it. You have to include a feature store in this project where the model will be stored as well as the dataset which you download will be stored. To save this model as well as dataset inside a artifact folder. And I've used AWS for this project. You can also try GCP or Azure to deploy this project. These are the assignments, and I've also added few flowcharts. So these are the flowcharts, you can use it for reference and you can also understand how our pipeline works. That's it guys. This is the conclusion for this project, and I'll meet you guys in an exciting new project.